Hello class, today we are going to be talking about plate tectonics. The objective that goes along with this lesson is 6.E.2.2. Explain how crustal plates and ocean basins are formed, move and interact using earthquakes, heat flow, and volcanoes to reflect forces within the earth. Please make sure you are following along with your guided notes as you go through this PowerPoint. Exploring inside the Earth. As you should remember from class, we know that scientists have been trying to dig a hole to the mantle. However, they have only reached the crust. Geologists have used evidence from rock samples and evidence from seismic waves to learn about Earth's interior. Geologists are scientists who study the forces that make and shape our planet Earth. Geology is the study of planet Earth. We already know a good bit about the mantle. Earth's mantle is made up of rock that behaves as a very viscous liquid. Remember that a viscous liquid is a very thick liquid, almost solid. The mantle is divided into layers based on the physical characteristics of those layers. If you look at the diagram below, you will see that the oceanic crust is to the left and the continental crust is to the right. You will also see right underneath the crust is the upper mantle. You should also notice that the upper mantle is about 350 kilometers deep. If you look to the right of your diagram, you will see that the lithosphere is located of the crust and the upper mantle, and the asthenosphere is located right underneath the lithosphere. We also know about the core. The core is made mostly of the metals iron and nickel, which remember are magnetic metals. It consists of two parts, a liquid outer core and a solid inner core. You also should remember that the reason the inner core is solid is because it's under so much pressure. You should remember from your heat energy unit that there are three types of heat transfer: radiation, conduction, and convection. Radiation is the transfer of energy through empty space, or as we know them, electromagnetic waves. Conduction is heat transfer by direct contact of particles of matter. Heat transfer is the movement of energy from a warmer object to a cooler object. This should be old news. Convection currents. Heating and cooling of a fluid changes in the fluid's density, and the force of gravity combine to set convection currents in motion. Convection is heat transfer by the movement of a heated fluid. Convection currents are the flow that transfers heat within a fluid. Convection currents in Earth. Heat from the core and the mantle causes convection currents in the mantle. This is how the heat is transferred. If you look at the diagram below, it'll show you the convection currents that are occurring in the mantle and in the core. Continental drift. We've talked a little bit about this, and we're going to go more in depth during this PowerPoint. There was a man named Wegener. That was his last name. Wegener's hypothesis was that all the continents were once joined together in a single landmass. Continental drift is the hypothesis that the continents slowly move across the Earth's surface. Scientists now believe that about 200 million years ago, a supercontinent known as Pangaea existed. This supercontinent was made up of all the continents on Earth. You can look at the diagrams below. To the right, you can see that that is Pangaea. That is where all the continents were combined. Evidence for continental drift, because we know that scientists always use evidence. Fossils are any trace of an ancient organism that has been preserved in rock. If you look at the small diagram of Pangaea, you will be able to see that there are some traces of some fossils. And then the continental drift is when the continents have moved away from each other, and you can see that those fossils have now moved to other continents as well. That is evidence of continental drift. We're going to talk a little bit about mid-ocean ridges on this PowerPoint, and we're going to go more in depth later. The East Pacific Rise is just one of the many mid-ocean ridges that wind beneath Earth's oceans. If you look at the map below, you will see at the very top represents the Earth's ocean floor. The mid-ocean ridge is the longest chain of mountains in the world. A sonar is a device that bounces sound waves off underwater objects and then records the echoes of these sound waves. The map also, if you look at the key, all of the red outlines are the deep ocean trenches, which we will also talk about, and the green is your mid-ocean ridge. This is a satellite image of those mid-ocean ridges. What is seafloor spreading? In seafloor spreading, the seafloor spreads apart along both sides of a mid-ocean ridge as new crust is added to the ocean floor. As a result, the ocean floors move like conveyor belts, carrying the continents along with them. If you look at the diagram, you will see that the new rock added to each side of the mid-ocean ridge. You will also see that this is the oceanic crust, and there is a molten material that is coming from the mantle that is causing the seafloor spreading. Again, we have some evidence for seafloor spreading. Several types of evidence supported the theory of seafloor spreading: eruptions of molten material, magnetic stripes in the rock of the ocean floor, and the ages of the rocks themselves. This is spreading the ocean floor apart. Subduction at trenches. You should know that the root word sub means under. In a process taking tens of millions of years, part of the ocean floor sinks back into the mantle through deep ocean trenches. Deep ocean trenches are deep underwater canyons formed where the oceanic crust bends downward. Subduction is the process by which the ocean floor sinks beneath or below a deep ocean trench and back into the mantle. So take a look at your diagram. You see the molten material coming from the mantle, causing the seafloor spreading of the mid-ocean ridge. You see that the older oceanic crust is going to be further from the mid-ocean ridge, and the newly formed oceanic crust is going to be very close to the mid-ocean ridge. Growing an ocean. Because of seafloor spreading, the distance between Europe and North America, which is our continent, is increasing by a few centimeters per year. That means that we're becoming farther away from Europe, not closer. And this is just a little funny cartoon at the below where it says this trip seems a little longer each time. So how do our plates move? The lithosphere is broken into separate sections called plates. The theory of plate tectonics explains the formation, movement, and subduction of Earth's plates. Scientific theory is a well-tested concept that explains a wide range of observations. Faults are breaks in the Earth's crust where rocks have slipped past each other. If you take a look at the map below, this is a map of Earth's lithospheric plates. You can see that there are some convergent boundaries, some divergent boundaries, some transform boundaries, some uncertain boundaries, and it's also showing you the direction in which the plates are moving. Remember that there are three kinds of plate boundaries. There are divergent boundaries, there are convergent boundaries, and there are transform boundaries. A different type of plate movement occurs along each type of boundary. A divergent boundary is when a rift valley forms when two pieces of continental crust are pulled apart. A transform boundary is when two plates slide past each other, and a convergent boundary is when two continental plates collide, forming a mountain range. That is on this diagram. A rift valley is a deep valley that forms along the divergent boundary. Plate boundaries. At the locations where two tectonic plates interact, a boundary between these plates exists. There are three types of boundaries that geologists observe. These boundaries are divergent boundaries, convergent boundaries, and transform boundaries. We will draw some of these diagrams in our notebook, so don't worry. Transform is where you see them sliding past one another. Divergent, they are going away from one another. And convergent, they are coming toward one another. Back to continental drift. It has taken the continents about 200 million years since the breakup of Pangaea to move to their present locations. This is how we see our continents today. And these are just some of the resources that were used to create this PowerPoint. That is all for today, class. If you have any questions, please feel free to fill them out in the comment section on your blend space. Ask me any questions that you are still confused about, anything that really interests you that you still have questions about. We will talk more about this in class. Make sure your guided notes are filled out.